Welcome to qnawire.
So this one is slightly more involved calculation involving a mass, in this case, that is moving with a certain velocity v1 I, and you have another mass that is stationary. We'll call that m2, but these masses are the same. And when they collide, you're told that the first one moves at 37.08 degrees with respect to the initial direction of motion. So that means that that first mass there is now moving at a certain angle here that is 37.08. And so that's the angle of the motion, and it has its velocity v1 final. And then the second mass, you're told that it moves perpendicular to this. So obviously it can't go this way because there's no way that this thing will essentially accelerate in this direction after this collision happens. So we can anticipate that the second mass is actually going to be going downwards. But if these velocities are perpendicular and this is 37, that makes that angle here 52. In my case, 52.92 degrees if you do it out all the way. So now you have, again, a scenario where you have one-dimensional motion turning into two-dimensional motion. So you need to treat these separately because momentum is indeed a vector. So in the x direction, at first, we want to find out what the momentum equations will tell us about the motion. So again, pi is equal to pf. So m v1I plus 0, because this thing is stationary, should be equal to m v1f, but we're looking at the x direction, so this is actually a component in x direction. So that will have a cosine 37.08 here, because to get the x component, again, you want to use the adjacent side over the hypotenuse, which is just the cosine here. So just a little bit of trick over here. Now, this is also moving in the x direction because there's also some component in the horizontal here. So we have to add that on there as well, but the same mass, so that becomes v2f. Again, so this is now a cosine 52.92 degrees. So this is the total equation in the x. And then now we go to another direction that is also equivalent. But now notice that initially there is no momentum in the y direction because there's no vertical motion. So that's equal to 0 on this side. But afterwards, there is a velocity in the y direction, and we are going to say that upwards is positive in this case. So we can say that m v1f, now sine for the complementary angle, for the complementary side, sorry, so 37.08. And now this is moving in the opposite direction, so that velocity will be negative. So this is m v2f, again, sine 52.92. So these are two equations, and from these two equations, you can actually solve for the velocities that you asked. So let's look at the second one here. So notice that the mass is the same, so you can go ahead and cancel those from these equations because if the mass is the same, then you won't need to calculate that at all. So now we know, so once you move this to that side, you can actually realize that v1f is equal to v2f sine of 52.92 over the cosine over the sine of 37.08. So this will give you an expression for V1 in terms of V2. And once you have this expression, you're going to go ahead and plug it in right here for V1 into that equation so we can find the other velocity. So once you have this number here, you're going to plug it in that case. So to maintain accuracy in this problem, it's a good idea to maybe keep these as sines or to keep the cosines as cosines and directly calculate it at the end in your calculator to make the answer as close to the actual answer as possible. So we know what the initial velocity is. They already showed us that it was 5 meters per second. So this here was 5 meters per second. And again, like I said, the mass is common to both these objects. So you can go ahead and just remove the masses from those equations. So we'll see that once we put this expression here, you're going to get a very long expression that will tell you that 5 is equal to, so V1F is right here, and we're going to replace it with this whole expression on this side here. So it's going to be V2F, so sine of that 52 degrees over sine of 37 degrees. So I just copied this whole thing and put it here in place of V1, but that is now also multiplied by the cosine of 37 here, right? So this is now that expression. And notice we also have another part of V2 here, and so we can just go ahead and add that. That becomes V2F cosine of 52 degrees. So to simplify this, I'm just going to say 37.08 degrees is angle A, and 52.92 is angle B, just to simplify the expression that I'm going to come up with. So this was 52, so that's B. This was 37, so that's A, and this was this is 37, so that's A, and this is 52, so that's B. So notice that you can find all of these except for VF, which means from this expression you can actually calculate V2F, because the only unknown that you have is just that V2F. So if you now simplify this, so you calculate this whole fraction, you calculate this whole fraction, you subtract, or you add them in this case, you're going to come up with an expression that gives you V2F as 3.24 meters per second. And that comes from the fact that, again, once you simplify all of these angles and add the coefficients, and then you divide 5 by that coefficient, you find the V2F. And once you have V2F, you know what V1F is in terms of V2F. So you're going to now have V1F as equal to this V2F that you have, so 3.24 multiplied by, again, sine 52, which is sine of that angle B, over the sine of 37.08, which is, just in case, this is in this case angle A. So you can go ahead and just compute that. Again, it's better to just put these angles as they are in the calculator so you don't induce errors from rounding up or down. So in this case, you get V1F as something around 4.288 meters per second. and that should give you all the velocities in this case.